Question 8 is a Group 2 question with a bit of mole calc and practical thrown in for good measure. Again, easily overlooked Group 2 stuff because it's only a very, very small topic really, but you know, they can really flesh it out, and this is an unstructured calculation question that's reasonably tough, okay? So, the idea here is that you're given the information about a powdered mixture, here's my solid, okay, which contains an as yet unknown proportion of completely dry anhydrous, so that means without water, mixture of group 2 chlorides, one of which is barium chloride and the other one is a magnesium chloride. So they're group 2 elements, okay? The mixture is then, or a small proportion of the mixture is then dissolved in water, and an excess of H2SO4, sulfuric acid, is added. A white precipitate then forms, and then some stuff was done to it to make sure that it was completely dry. And the mass of this solid was, here's the number. So the first thing is, this point, identify the white precipitate, because if you can't do that, you're stuffed really for the rest of the question. So you're supposed to know, right, that in group 2, ignoring beryllium because it's weird, okay, that, in fact I've got a periodic table so I don't know why I did that, but magnesium to barium, that's the relevant section, okay. There are two opposing trends. One is that the hydroxides get more soluble as you go down the group, and the other is that the sulfates get less soluble as you go down the group, which means that if we're dealing with sulfates, the least soluble sulfate will be barium sulfate. And again, that's a fact you're supposed to know because of this medical application of it. So barium sulfate is extremely insoluble, and that means that in this scenario, if the dissolved barium chloride and dissolved magnesium chloride, which were mentioned earlier in the question, right, were mixed with sulfuric acid, barium sulfate would be the identity of the precipitate, okay? So that's not too bad if you've learned all your facts, okay? But it's an important thing. So white precipitate, BaSO4. Alright, that's the formula for barium sulfate. Because it's a group 2 metal ion, you only need one sulfate ion to counterbalance the charge. So it's just BaSO4. So that's going to be 1 mark, isn't it? Right? Then there's a load of calculations to do. Calculate the percentage by mass of magnesium chloride in the powder. So straight away, there's an easy way to fall afoul of this. It's asking you about the other chloride. So even though the barium chloride was the one that underwent this physical change to precipitate out to form this thing that we've just identified, you're actually tracking back to the other component of the mixture. Okay? So let's just get our facts in order. White precipitated barium sulfate, and it weighs 0.764 grams. Okay? That link is important because it's very easy to miss, right? The thing that was measured, the thing that had its mass measured, was the barium sulfate precipitate. If you read through the paragraph again very carefully, then you'll kind of see how that tracks, right? So that's the only thing we know the mass of. So we know the formula of barium sulfate, we know the mass, so straight away we can calculate the MR of barium sulfate, and we can calculate the number of moles, because moles is mass over MR. Okay, so that's going to be 0.764 divided by, need to check the periodic table, this one, 137.3. So I'm going to do this up here just so it's a bit tidier, right? At least I'm going to try. There we go. 137.3 plus, so we've got sulfur, 32.1 according to the AQA A-level periodic table, but I just thought I'd check. Plus 64 because there's 16, oxygen 16, and there's 4 of them. I'm pretty happy about that, so I'm just going to leave it as it is, right? But you should double check if you're not sure. So the RFM, not a well-known one because we don't do lots and lots of calculations with this compound. 233.4. So then I've still got the number in my calculator, so I'm just going to type 0.764 divided by answer. Okay, so we get 3.27, and then it's a long number, but that times 10 to the minus 3 moles. That's probably worth a mark, okay, for calculating the number of moles of barium sulfate. However, there's more to do here, and the next part is another tricky bit, okay? So, just to clarify, what we've just calculated is the number of moles of barium sulfate. So far, we still haven't even gone back to the original mixture. We're still dealing with the precipitate. The thing you need to understand about the precipitate is its formation will have looked like this. Okay, you don't need to write the equation for this question, but it helps, right? And the reason that it helps is if you look at this as a balanced symbol equation, right, and we could put the state symbols in and everything, but we know it's a precipitate, so let's not bother. But 1 mole of that tracks back to 1 mole of that, right, because there's no balancing required, there's no coefficients in front of the formulae, so it must be 1 to 1. What I'm trying to build towards is the statement that there must have been this number of moles of barium chloride. If that bothers you, then you need to take time with it and really kind of try and digest it and get your head around it. All I'm doing is applying the known number of moles of barium sulfate, which are just figured out by calculation, to this relationship that's shown in the equation, which you don't actually have to write, but it helps to explain it. So now we have a number of moles of barium chloride, okay? So, if we've got the moles and we've got the formula, we can calculate the mass, right? So, mass is moles times mR. So again, we're going to have to calculate the relative formula mass of barium chloride. So what was barium? 137.3. Okay, and we've got 2 chlorines, so 35.5 plus 35.5. Okay, and the relationship here is mass is moles times mR, so 3.27 times 10 to the minus 3 multiplied by all the stuff that adds up in those brackets. I still have this number in my calculator, so I'm just going to hit multiply by, open brackets, 137.3 plus 35.5 plus 35.5. Okay, so answer is 0, excuse me, there we go, 0.68, and then if we do it to 3 sig figs, 2 grams. Okay, it's actually 0.6818, blah, 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 but let's call it 0.682 grams. But again, in terms of how we're answering questions and laying our answer out, just remember that's the mass of barium chloride. And again, we'll have got some credit so far. In fact, we're probably at 3 marks now. But there's one thing still to point out, which is, I mentioned this earlier, we want to know the percentage by mass of magnesium chloride. So the important number now is that number, because if 0.682 grams of barium chloride were present in the original mixture, we can now subtract that number from 1.056. So let's lay it out. 1.056 minus 0.682. Okay, which means there was 0.374 grams of magnesium chloride, but it wants it as a percentage by mass. So now 0.374, which is the number that I've still got on my calculator, divided by the total mass, because that's how we do a percentage by mass calc, multiplied by 100. And we get 35.4%, which makes sense really, because this number's pretty close to 1, and this number is 0.3, well, 0.374. So 35.4%. That looks like a good answer. And that'll be our final mark. So there's actually quite a lot going on in this question. Things to point out, because I don't always model necessarily the best sort of way to lay out working, but things to point out, if you're not sure about your relative formula masses, take them very slowly, because it's really, really easy marks to lose. For example, down here, I know that chlorine has a relative atomic mass of 35.5, and I kind of knew about the sulfur at the top as well, but it's worth checking, right? I'm just not doing it because it's not necessarily the point of this question. There's more going on than that, but it's worth checking because you always have this, like I keep saying, in front of you, right? So just be kind of careful about that. On top of that, don't try and always be clever and do everything in one step in your calculator. Again, I was getting a bit kind of, what's the word? Fatigued with the question, so I skipped through it a little bit, but really what I should have done is put together the RFM and then written it as one number. Okay, that would have been better practice to model, and that way, instead of just putting RFM here, I could have shown you the number. I know it's correct, or at least I'm pretty sure it's correct, but it's still not necessarily the best way to do it. Okay, so sorry for that. That's me modelling slightly poor behaviour, but it's just something to point out. Let's move on to MCQs.